So in the previous class, we are discussing about the glycosides. Okay. In the previous class, we are discussing about the glycosides. So till now, we have discussed the basic definition of glycosides. What are the parts of characteristics, functions, classification according to the glycon part, classification according to the aglycon part. Okay, and classification according to aglycon part is very important. Okay, next we'll discuss about the anthraquinone Okay. Next, we'll discuss about anthraquinone glycoside containing the aloe and senna and the cyanogenetic glycoside, the bitter almond. Okay. So, anthraquinone glycoside are the glycosides containing the anthracene derivatives. They are the anthracene and derivatives and their derivatives. So hydrolysis of these glycosides can yield I-glycone, which are mainly di, tri, or tetrahydroxyanthraquinones in nature. Okay. So anthraquinone glycosides are the laxative and purgative property containing drugs. Okay. Mainly the anthraquinone glycosides have the laxative, purgative, and also in some cases cathartic property. Okay. So first drug of anthraquinone glycoside is the aloe. We all know about aloe. Aloe in Bengali it is known as Ritokumari. There are different species of aloe present. Okay, different species of aloe present. Aloe is mainly the latex or the juice of the various species of aloe. Uh, Aloe is mainly the not the dried latex. It is mainly the dried juice of the leaves of various species of aloe, like the aloe barbadensis, aloe ferox, aloe peri, aloe africana, aloe spicata, and the Indian variety that is the aloe vera. Okay, belonging to the family of Liliaceae. Aloe is the dried juice mainly obtained from the leaves of different species like the aloe barbadensis, aloe ferox, aloe peri, aloe africana, aloe spicata, belonging to the family of Liliaceae. Uh, Aloe barbadensis is also known as Curaçao aloe. Aloe ferox is known as Cape aloe. Aloe peri is known as Socotrine aloe. And the aloe africana and aloe spicata is known as the Cape aloe. Okay. Depending upon the geographical source, the different species of the aloes are named. Okay. And mainly aloe is indigenous to Africa. Aloe is mainly indigenous to eastern and southern Africa, mainly found or mainly grown in the Cape Town and Zanzibar and islands of Socotra. Okay, it is also found in Europe, Caribbean island, and many parts of India also. Okay. Mainly in India, it is found in the northwest Himalayan region. Okay, northwest Himalayan region. Uh, aloe is a, you can say, aloe is a thought. Okay, and it has mainly large, succulent, large leaves. The leaves are sessile in nature, and for cultivation, roots are used mainly for cultivation. Root suckers are used for propagation. Root suckers are used for propagation. Okay. And the plant can also be grown from the leaves also. Okay. So There are different species of aloe, namely the Morocco aloe, Cape aloe, Socotrine aloe, Zanzibar aloe, and also the aloe vera. Okay. And mainly the preparation is done by the preparation of aloe is done by giving a transverse cut at the base of the fleshy aloe vera leaf. Okay, aloe leaf. Mainly the preparation of aloe is done by uh, making a transverse cut or incision at the base of the fresh leaf from where the juice oozes out, juice oozes out and collected in a V-shaped wooden trough, V-shaped wooden trough, and they are uh, they are stored in kerosene tins. It is very important that aloe juice are mainly stored in kerosene tins. Okay. And, and after after collection, the juice is boiled in large copper pans. The juice is boiled in large copper pans. During boiling, the latex which is present in the juice evaporates and the juice becomes thickened further, and the thick juice is then further used and processed. Okay. So there are two important points in the preparation of aloe. One important point that the leaves are transversely cut and it is placed in a V-shaped wooden trough, and the juice is collected in a V-shaped wooden trough, and the juice are collected in a kerosene tin after cutting, after immediately cutting, and after collection of the juice is boiled in large copper pans where the latex is evaporated, and then further the juice becomes thick, and the thick juice is further used or processed in different purposes. Okay, this is the main basic preparation of the all types of aloe. And one more important point that aloe is mainly stored in kerosene tin and also stored in boat skin or canvas. Okay. Boat skin or canvas. Next is the uh, next is the macroscopical characters. Uh, the characters vary from plant to plant. Okay. The mainly the leaves are green in color, sessile in nature. Uh, um, the aloe has a not very strong smell, and the taste is bitter. This very bitter taste. Okay. And the juice is mainly transparent or light greenish in color, or when the juice after collection becomes dark brown or greenish brown in color or olive brown in color. The Curaco aloe mainly, the Curaco aloe are mainly Curaco aloe and the Cape aloe are mainly have strong odor of iodoform and intensely bitter in taste, and brownish black in color. The Cape aloe are dark brown in color and also have bitter taste. The Socotrine aloe are brownish yellow in color. Socotrine aloe are brownish yellow in color and also have intensely bitter taste. And the Zanzibar aloe are liver brown in color. The Zanzibar aloe are liver brown in color, which have very disagreeable odor and bitter taste. This is the main distinguished characters of the different types of aloe. Next is the chemical constituents. What are the main chemical constituents present in aloe? Aloe mainly contains the anthraquinone glycoside. Aloe mainly contains the anthraquinone glycoside. The active constituents of aloe is aloine, which is a mixture of glucosides, and mainly it contains the barbaloin as the chief constituent. It contains the barbaloin as chief constituents, and the percentage of aloin differs in the different species, like 4 to 5% present in Cape aloe, but 4 to 5% of aloe is present in Cape aloe, 18 to 25% is present in Curaçao aloe, okay, etc. And the other constituents which are mainly present are the aloe imodine, and resin 16 to 63%, and also glutathione oil. And as already discussed, that the main principal constituents of aloe are the aloin, barbaloin, isobarbaloin, beta barbaloin, aloimodine, and resin. Just a minute. So, the main chemical constituents or the important constituents are the barbaloin. Barbaloin, which is a C glycoside in nature, okay, and other constituents are aloe, imodine, anthro, imodine, isobarbaloin, beta barbaloin, okay, and resins. So, and other from this drug, the aloe also contains Cyclopanic acid, cyclopanic acid, choline, and galactolonic acid, etc. Okay. And the as barbaloin is the main chemical constituent, the amount of barbaloin is the amount of barbaloin differs from in different species or different varieties of aloe, and mainly the Curaçao aloe contains the maximum 22% of the barbaloin. Okay, and aloe vera, which is the Indian variety, contains 3.5 to 4% of the barbaloin. And Cape aloe contains uh, less amount of berberine. Okay, and the resin, which is mainly the 16 to 63%, which is present in the aloe, is known as aloesin. Okay, the resin which is present in aloe is known as aloesin, and the aloesin resin is responsible for the purgative property of the aloe. Okay, the resin aloesin is responsible for the purgative property of the aloe. Okay. So next is the uses, as the anthraquinone glycoside containing drugs are mainly have purgative and laxative property, and in some cases also have strong catalytic actions. So mainly aloe is used as purgative, and it is used in treatment of constipation, and also used as a compound of benzoin tincture, and ointment of aloe gel is used in treatment of inflammation in minor burns, okay, skin irritations or skin inflammation, and also used in different skin diseases, wounds, okay. So and aloe is mainly used for its purgative property, and also aloe has different other properties that it is also used as anti-wrinkles. Aloe is also used in hair preparations, hair care preparations, skin care preparations. Okay, so aloe has different uses. Next is the chemical test. As the different varieties of aloe has different types of chemical test, but the main general chemical test for aloe and for the anthraquinone glycoside is the modified Bronsted test, which I have discussed in under Sena drug. Okay, we'll discuss later. Uh, Next is the adulterants and substituents. The adulterants and substituents of aloe. The adulterants mainly the substituents or the adulterants which are used in replacement of the official drug is the natal aloe and natal aloe, which somehow resembles the cape aloe in some microscopic characters. Okay. And natal aloe contains nataloin, homonatalian, homonatalian as its main chemical constituent. Okay, and the resin, which is the nataloresinocanol, the main resin, which is the nataloresinocanol. It is present in natal aloe, and by this we can distinguish between the official drug and the subsequent drug. And the natal aloe has weak purgative action. Natal aloe has weak purgative action. Okay. Next is the mocha aloe. Mocha aloe, it is blackish in color, brittle in nature, and has very strong odor. Okay. So these are the main two adulterants. One is the natal aloe and another is the mocha aloe. Okay. And sometimes aloe also adulterated with black catechu and pieces of iron and stone. Okay. Next drug is the sena. Sena in Bengali it is known as sona pata. Okay. Sena it is the leaves and also the dried pods of sena are used. Uh, there are mainly two varieties. One is the Sena Cassia angustifolia, which is known as the Indian Sena, and Cassia acutifolia, which is known as the Alexandrian Sena, belonging to the family of Leguminosae. Okay, and it contains mainly Senoside A and Senoside B. Okay, it mainly contains the Senoside A and Senoside B. And Sena occurs in leaflets. Sena occurs in leaflets. The leaflets are mainly 2 to 4 centimeter long, and the Sena pods are 4 to 5 centimeter in long. Sena pods are 4 to 5 centimeter in long, and the Alexandrian Sena leaf is somewhat longer in shape than the Indian Sena leaf. Indian Sena leaf are somewhat small in shape, and the Alexandrian Sena leaf are somehow long in shape. Next is the chemical constituents, main chemical constituents, and as Sena contains the anthraquinone glycosides, the main glycosides are the phenoside A and phenoside B. It also contains phenoside C and phenoside D. Phenoside A and B are the stereoisomers of each other. They are mainly the dimeric glycosides of the rain diantron. Okay. Apart from phenoside A and phenoside B, phenolene also contains rain, camphorol, which is a flavonoid, aloimodine, isoramidine. Okay, and apart from this, it also contains mucilage, resin, phytosterols, calcium oxalates, and the Alexandrian Sena and the Tinglebelly Sena or Indian Sena can be distinguished by the different characteristics like the stomatal index, Palisade ratio, and the phenolate number. Okay. Mainly, these are the microscopical characteristics or the leaf constraints of the drug, and by this microscopical characteristics, we can easily distinguish between the Alexandrian Sena and the Indian Sena. Okay. And the percentage of phenocide in the percentage of phenocide in leaves and pods is more in compared to Indian Sena. The percentage of the phenocides in Alexandrian Sena in leaves and pods is more than the Indian Sena. Okay. So these are the main chemical structures of the phenoside A and phenoside B. Phenoside A is levoinform and phenoside B is meso. And you can see in this structure the other phenoside C and phenoside D. And the main, this is the rain antron. Phenoside A and phenoside B are the rain diantron. Diantron are dimeric form of the rain antron. It also contains aloimodine, imodine. These are the main structures which are present in the chemical constituent of Sena. Next is the Sena also contains two naphthalene glycosides, which is known as the T-labeled glycoside and 6-hydroxymucilin glycoside. And next is the use. As Sena also contains the isoquinone glycosides, they mainly act on the colon and stimulate its muscle. It acts as irritant laxative, and small dose it is laxative in nature, and large dose it is purgative in nature. And in tribal areas in the folklore medicine, it is Sena is also used as expectorant and also used as wound healing and treatment of skin diseases, some gonorrhea, and also used in fever, dyspepsia, hemorrhoid. Okay. These are the traditional use of the folklore medicine or used in folklore medicine. Okay. Next is the adulterants and substituents. And the main adulterant of Sena is the dog Sena, Palsy Sena, and Arabian Sena. Dog Sena, Palsy Sena, and Arabian Sena. One of the important points in Sena is the difference between the Algerian Sena and the Indian Sena. This can be distinguished, or the difference can be made on the basis of the microscopical characteristics, which I will provide you in the notes. Okay, I will give you in the classroom classroom notes. Next is the chemical test. Next is the chemical test, and The main chemical test is the modified Brown-Taylor test and the Brown-Taylor test. Anthraquinone for anthraquinone glycoside, the main chemical test is the modified Brown-Taylor test. And this is the Brown-Taylor test where the leaves of the senna are extracted with or boiled with disulfuric acid, and extract is prepared. And with the filtrate or the extract, benzene or ethyl or chloroform is added, and there will be two layers from which the organic layer is separated. And with the organic layer, ammonia is added slowly. The ammoniacal layer will show pink color or red color due to presence of the anthraquinone glycoside. In case of modified Brown-Taylor test, here one more ingredient is used, which is the ferric chloride. Okay. Uh, Ferric chloride solution is used after making the extract with disulfuric acid. Then ferric chloride is used. After that, benzene, ether, or chloroform is added and shake well. And rest of the steps is similar like the Brown-Taylor test. Okay. So this is the modified Brown-Taylor test. And I've already discussed what is the difference between the modified Brown-Taylor test and the Brown-Taylor test. Okay. Next is the bitter almond. Next is the bitter almond. Bitter almond is the cyanogenetic glycoside containing drug. Bitter almond is the cyanogenetic glycoside containing drug. And the synonym is Amygdalus amara. The synonym is Amygdalus amara. It is mainly the bitter almond is mainly the dried ripe seeds. Bitter almond is mainly the dried ripe seeds of Prunus amygdalus, family Rosaceae, and it is native to Iran and Asia. It is native to Iran and Asia. Okay. It is also found in France, Morocco, Portugal. There is also another variety of almond which is known as the sweet almond, and the scientific name for sweet almond is the Prunus communis. Okay. And next is the macroscopical characteristic color. The bitter almond seeds are mainly brownish color, odorless, bitter in taste, about 20 millimeter in length, 120 to 125 millimeter width, and 10 millimeter thickness. Okay. It is somewhat flattened or oblong in shape, as it is a cyanogenetic glycoside containing drug, cyanophore glycoside containing drug, yields hydrocyanic acid as one of the product of hydrolysis. On hydrolysis of bitter almond yields hydrocyanic acid, and this type of glycoside is mainly found in the family of Rosaceae. Okay. And next is the chemical constituents. Bitter almond mainly contains the fixed oil, protein, an enzyme emulsin, and bitter crystalline bitter glycoside, which is known as amygdalin. Bitter glycoside, crystalline glycoside, which is known as amygdalin, which is mainly present in 1 to 3%. Also contains volatile oil. This amygdalin on hydrolysis is decomposed to benzaldehyde and hydrocyanic acid. This amygdalin gives benzaldehyde and hydrocyanic acid on hydrolysis or on decomposition. Bitter almond oil also contains a mixture of different fatty acids, glycerides of oleic, linoleic, palmitic, myristic, etc. Also contains The purified volatile oil of bitter almond also contains the hydrocyanuric acid. And sorry, the purified bitter almond oil, volatile oil, the purified volatile oil, the hydrocyanuric acid is removed, so it only contains the benzaldehyde. The hydrocyanuric acid is very poisonous, and so it is not due to the presence of the hydrocyanuric acid, it makes the drug unsuitable for the internal consumption. The sweet almond do not contain the amygdalin, bitter glycoside, so they are not bitter in taste. So the sweet almond is sweet in taste due to the absence of amygdalin, which is the bitter glycoside, and due to the absence of amygdalin, uh, so they doesn't have any volatile oil, and it doesn't contain hydrochloric acid. And the bitter almond oil mainly contains 80% of benzaldehyde and 2 to 6% of the hydrochloric acid. 80% of the benzaldehyde and 2 to 6% of the hydrochloric acid. As the sweet almond doesn't contain the amygdalin, so it doesn't contain also the hydrochloric acid. Okay. So sweet almond oil can be consumed. Sweet almond oil is suitable for the internal consumption. This is the main basic difference between the sweet almond and the bitter almond. Next is the use. Bitter almonds are used as sedative due to the hydrocyanuric acid content. The oil is used as emulsion in different skin preparations, skin lotion. It's also used in preparation of bitter almond water in perfumery and also in form of liquors. And bitter almond oil is not suitable for use for flavoring purposes of food, as due to the presence of the amygdalin and also due to the presence of the hydrocyanuric acid. So this is the main use of bitter almond. So aloe and senna are the anthraquinone glycoside containing drugs, and the bitter almond is the cyanogenetic or cyanophore glycoside containing drug. And these are the main important glycosides which are present in your syllabus. Apart from this, there are different other drugs also, and in the another section, in the chapter containing the steroids, cardiac glycoside, and cytophenol, will discuss about the other glycosides like the liquorice, diaspora, and digitalis. Digitalis is the cardiac glycoside, and liquorice and diaspora is the saponin glycoside. Okay. Licorice and diaspora are the saponin glycoside, the saponin containing glycoside, and digitalis is the cardiac glycoside. So, up to this, we have discussed the aloe, senna, different types of aloe, and so Nobin Chhetri, Nobin Chhetri আছো? Hello, Nobin
হ্যাঁ
Chhetri.
হ্যাঁ ম্যাম
আচ্ছা বলো তো, which resin is present in aloe? What is the name of the resin present in? What is the name of the resin present in aloe? আলোর মধ্যে একটা রেজিন থাকে, রেজিনটার নাম কি? কে বলতে পারবে? কে বলতে পারবে? অনুষ্কা চ্যাটার্জি, মৌমিতা দাস, প্রতীক বাড়ি, রাজদীপ কর্মকার, অনামিত্র, কে বলতে পারবে? বলো, এইমাত্র বলেছি আলু দিয়েই নাম। The resin which is responsible for the purgative property of the aloe. The resin which is responsible for the purgative property of the aloe. বলো, কে বলতে পারবে?
ম্যাম অ্যালো এমোডিন।
না, অ্যালোমোনিন না। আর কে বলতে? বলো, আরেকবার চেষ্টা করো। অ্যালোমোনিন নয়। অ্যালোইসিন, অ্যালোইসিন, ঠিক আছে? অ্যালোইসিন, অ্যালোইসিন is the resin which is present in the aloe and which is responsible for the quantity property of the aloe. Okay, aloysian. So, arekta question. What are the main glycosides of Sena? What are the main glycosides of Sena? What are the main glycosides of Sena? কে বলতে পারবে? What are the main glycosides of Sena? বলো।
সেনোসাইড
A B C D.
A B C D এর মধ্যে কোনটা ইম্পর্টেন্ট?
সেনোসাইড এ এন্ড বি।
Phenoside A and B, exactly. Phenoside A and B. আচ্ছা, last question. Which compound is responsible for the bitter taste of the bitter almond? Which compound is responsible for the bitter taste of the bitter almond?
Amygdalin.
Amygdalin. Okay, exactly, amygdalin. And on hydrolysis, amygdalin yields. On hydrolysis, amygdalin yields. Amygdalin
Hydrocyanic acid.
বলো।
Hydrocyanic acid.
Hydrocyanic acid and আরেকটা কিছু পাওয়া যায়।
Ma'am, benzaldehyde.
Yes, benzaldehyde and hydrocyanic acid. Okay. So, with this glycoside ends. In the next class, we'll start with steroids, triterpenoids. Okay, steroids, triterpenoids, and cardiac glycoside. Okay. In the next class, we'll discuss about liquorides, diasporia, and distals. Sorry, in the next class, we'll discuss about digitalis, liquorides,